Right, in this lecture we will be seeing proton exchange membrane or solid polymer fuel cells in detail. So what is the electrolyte in this type of fuel cell? It is a solid polymeric membrane fitted between two platinum catalyzed porous electrodes. So we have already discussed that we need to have catalyst for having fast reactions. Generally they are slow in reactions, but if you add catalyst then only the speed of reactions will be more. So if you see in this figure, we have a polymer electrolyte membrane in between, and then we have catalyst layer just beside that, and even right side and left side we have catalyst layers, and beside that we have anode diffusion layer, cathode diffusion layer. Right, that means this diffusion layer which is having catalyst layer and diffusion layer, they are combinedly called as cathode. Right, even to the left side we have catalyst layer, diffusion layer, they are combinedly considered as anode, and in between anode and cathode we have polymer electrolyte membrane. Okay, right. So what is beside that? Beside anode and cathode we have a Teflon mask, and we have outside bipolar plate. They are symmetric. Whatever is there on the left side of the membrane will be there on the right side also beside cathode. Okay, so the PEM fuel cell is made up of bipolar plates, a catalyst, electrodes are nothing but anode and cathode, and a polymer membrane which is electrolyte. And their distinguishing features include lower temperature and pressure ranges from 50 to 100 degrees centigrade, and a special proton conducting polymer electrolyte membrane. So here MEA is nothing but membrane electrode assembly. So this membrane as well as anode cathode electrodes combinedly considered as membrane electrode assembly, which is given as MEA. Right, just after MEA you can see we have Teflon masks as well as bipolar plates. Okay, let us see the chemical reactions and the otherwise working. So we have anode, cathode, electrolyte in between. So oxygen air is coming from downwards, fuel in, that is hydrogen is also coming. So whatever is excess fuel or that is already used H2O, H2 can also be taken out from upwards. So here towards the cathode side the coming out things are water as well as heat. Right, and the electrons which are produced in the chemical reactions will be flowing from anode to cathode. This is common in all the fuel cells. Right, the electrons will be coming out towards the cathode from outside. If you connect any load in between, it will be taking current. Right, that means there will be some voltage across the anode and cathode terminals of the fuel cell. So if you connect any load, the current will be passing. That is what indicated here. So the anode reaction is hydrogen will be decomposed into 2 hydrogen ions and 2 electrons, and at cathode we have half O2 plus 2 H plus ions which are coming out at anode will be coming towards the cathode. Since we are supplying oxygen at cathode, they will be combined along with the electrons to give rise to hydrogen, H2O. Right, and the overall cell reaction is nothing but 2H2 plus O2 gives rise to 2H2O. Okay, this overall cell reaction is the one which indicates the base inputs and base outputs. So the electrons will be anyways taken by the load. So what are the overall inputs, like overall for overall cell reaction? Hydrogen in, oxygen in, and H2O out. This is what given in the overall cell reaction, and of course all these are there with respect to stoichiometry conditions. So chemistry knowledge is required in order to understand these things very clearly. right? But as far as our course is considered, it is not so important to understand all those things. Okay, you just understand it as an overview, that's it. So there are newly formed protons which permeate through the polymer electrolyte membrane to the cathode side, right? And the electrons travel along the external load circuit to the cathode side of the membrane. What is that? MEA? MEA is nothing but membrane electrode assembly, right? Yes. So the electrons travel along external load circuit to the cathode side of the membrane electrode assembly, thus creating the current output of the fuel cell. And meanwhile, a stream of oxygen will be delivered to the cathode side of membrane exchange assembly, membrane electrode assembly, and at the cathode side, oxygen molecules combine with protons passing through the polymer electrolyte membrane and electrons arriving via external circuit to produce water molecules. So that is what overall cell reaction. So hydrogen plus oxygen will be giving to you water molecules. That is what given in text here. And this process involves the recombination of hydrogen protons and electrons with oxygen molecules, resulting in formation of one water molecule. Right, this is the same process, whatever is mentioned here. So there are different applications for these type of fuel cells, and despite their applications in transportation, they can also be utilized for fixed and portable power generation. Portable power generation means like a diesel generator we have, which can be taken, like they can be transported. Portable means transported, right? These fuel cells can also be used in that manner, and they can be developed for stationary fuel cell applications and portable fuel cell applications. And they are a leading candidate to replace the aging alkaline fuel cell technology which was used in space shuttle, right? And they are being applied for light duty, that means 50 to 100 kilowatt, and medium duty 200 kilowatts range, and also power generation for residential premises, that is for 2 to 10 kilowatt, and commercial premises maybe up to 500 kilowatt. And even smaller portable generators and battery replacements can also be done with the help of PEMFCs. And here portable refers to something that is easily movable, just now I said, right? So this is all about PEMFCs. We will see the next type of fuel cell in the next lecture. Thank you.